Good morning, everyone. I am V. Hariprasad from PG1 of JK Business School. I am going to explain a very important topic in the machine learning concepts, the concept of overfitting and underfitting. Let's we go through the deep explanation of the definitions overfitting and underfitting. Overfitting. It occurs when a statistical model or machine learning algorithm captures the noise of the data. It occurs when the model or algorithm fits the data too well. Underfitting, when a statistical model or machine learning algorithm cannot capture the underlying trend of the data. Next is how to limit overfitting. This thing we could able to see that both the overfitting or the underfitting can lead to poor model performance, but by far the most common problem is applied in the machine learning is overfitting itself. In such a way, the problem of this evaluation of machine learning algorithms on training data is different from the evaluation we actually care about the most, namely known algorithms of the unseen data. This is the concept of the overfitting and underfitting capacity models. This thing I am going to explain a deep of it. First of all, overfitting. It is a model learns the detail and the noise in a training data to the extent that it negatively impacts the performance of the model or new data. This means that the noise or random fluctuations in the trained data is picked up and learned as concepts by the model. The problem is that these concepts do not apply to new data or negatively impact the model's ability to generalize. Next one is underfitting. In this model, we can either the model to be a trained data nor generalize to new data. In this underfit missions, performance on the learning models is not a suitable model and it will be obvious to be have poor performance on the trained data or training data. It is often not discussed as it is easy to detect to be given a good performance metric. This remedy is to move on and to try alternative machine learning algorithms. Nevertheless, it doesn't provide a good contrast to the problem of the overfitting. This part is the importance of the graphical representation of the overfitting and underfitting models. This both shows us the true curves and the fitted curves on the overfitting and underfitting concepts. These both trade-offs that may show us that there could be a true problems that occur when training a model, not enough signal or too much noise. But on the underfitting, we could able to see the trained data is when the loss is not as low as it could be because the model hasn't learned enough signals. But on the overfitting, we could able to see the trained set is when the loss is not as low as it could be because the model learned too much noise. This trick to train deep learning models in finding the best balance between the two graphical representations of this overfitting and underfitting concepts. This part is slowly called as the early stopping. Early stopping will be showed us in the validation and trained data to be in a graphical representation. This shows us the overfitting and underfitting curves in the training models of the validation process. These learning curves will make us to understand the loss when occurs between the validation and the training test data in a machine learning concepts. This will utilize us to be analyze whether it could be better or somewhat like how to stop the early process of validation loss to be stopped earlier. This will exactly shows us the validation loss and the normal loss of overfitting and the underfitting concepts. These concepts will be surely taken out to be in a couple of ways of getting more signals out of training data uh, while reducing the amount of noise. The training loss will go down either when the model learns signal or when the learn noise or when it learn noise. But the validation loss will go down only when the model learns the signals. Whatever the noise the model learned from the training set won't generalize to new data. So when a model learns signals, both curves go down, but when it learns noise, a gap is created in the curves. Ideally, we could create models that learn all the signals and the noise. This will practically never happens. Let us see a small example of the overfitting and the underfitting concepts.
Say there are two kids who have prepared for a mathematics examination. First kid, Tom, only learned additions. He skipped subtractions, multiplications, and divisions. Second kid, Mary, has a really good memory and she memorized all the problems from the textbook. In the exam, Tom will only be able to solve questions related to additions and will fail in questions related to subtractions, divisions, and multiplications. On the other hand, Mary will only be able to answer questions if they were from the same textbook which she had memorized. Mary will falter if she encounters any question which was not there in the textbook or if the question comes from any other textbook. Both Tom and Mary will not be able to perform well in the exam. Machine learning algorithms also have similar behavior. Sometimes the models these algorithms generate are like Tom, where they learn from only some part of the training data. In such cases, the model is called to be underfitting. And sometimes the models memorize the entire training set, like Mary. They perform really well on the known instances but falter badly on unknown instances.
Thank you.